Okay, notes day 10 is about de Moivre's theorem. That's how you say this. It's not de Moivre or anything like ridiculous like that. It's de Moivre's theorem. So this is the last part of the chapter. We're going to be raising polar numbers to a power. And then we're also going to be solving equations that involve complex numbers, more than one solution. So there's one real solution and then a number of extra solutions to add up to the power of x. So we'll get down to that at the bottom. So the formula for de Moivre's theorem is rather simple. So what we're going to do, this n power, that gets brought inside to the r and the thetas. But the thetas you don't take to an n power, you multiply. So we have to have it in polar form first, so r cis theta. And this is going to be r to the n multiplied by cis n theta. So we multiply the theta by that power, and we take the r to the n power. And what we'll end up doing is going backwards when we solve equations. So it is rather simple, but the goal, of course, is to get it in polar form first. So number one, it's already in polar form. So let's rewrite this quick with, we don't have to rewrite it. Let's just leave it the way it is, 2 cosine sine. So when we bring the 3 in, this power, that's coming inside, and going to affect the 2, the pi over 3, and the pi over 3. So this becomes 2 to the third multiplied by cosine 3 pi over 3. So I'm multiplying 3 times pi over 3 plus I sine 3 pi over 3. And then we simplify, so this would be 8 cis pi. Okay. So now we just evaluate this. Okay. So I'm going to turn this into rectangular form. So this would be 8 times the cosine of pi, which is -1, plus I sine pi, which is 0. So this ends up being 8 plus 0i, or in other words, -8. So what happened here, and what we're doing, is if we look at this original polar equation, the polar expression, excuse me, which this 2 cosine pi over 3, I sine pi over 3, if I convert that to rectangular, it would be 2 multiplied by the cosine of a 60, which is 1/2, plus I sine of a 60, which is root 3 over 2. And then if I multiply in that 2 and distribute, this would be 1 plus root 3i. So this, in the original problem, is your complex number in rectangular form. What we're doing with that third power is taking 1 plus the square root of 3i and raising it to the third. Where normally you would need 3 parentheses and you'd be foiling, multiplying it out. It would be taking a long time to do. Nobody would like to do it. But now with de Moivre's theorem, all you have to do is convert it to polar, which it already was in polar, use the theorem, and then write your final answer, which is just going to be 8. So 1 plus root 3i to the third power is just -8. Maybe I just said 8 and then -8. Okay? So that's our goal here, raising it to a power and simplifying it. In number 2, this starts in rectangular form, and I need to convert this to polar form. So we need to find r, and we need to find theta. So one thing that we could do, that we could continue to do is first realize what quadrant this is in. What quadrant is it in, everybody? Good job. It is in the third quadrant. So that would be going over 8 to the left, down 8 root 3. So remember our geometry and special right triangles. This would be 16. You double the 60-90 side, which would make this your 60. Okay. So then we know that this would be what in our cis theta? So it would be 16 cis theta is 60, but you're in the third quadrant, so what angle is that? Good, 240 degrees. So we converted it to polar form, and now we're going to raise this to the 1/4 power using de Moivre's theorem. So the rule, we're going to take 16 to the 1/4, which I hope you remember from algebra. 16 to the 1/4 power is the 4th root of 16, multiplied by cis 1/4 times 240. So the 4th root of 16 is 2, cis 1/4 of 240, you just divide 4 into 240 and you get 60. So that's our complex number taken to the 1/4 power. So now I'm going to convert this back to rectangular form. So this would be 2 multiplied by the cosine of a 60, which is 1/2, plus I sine 60. The sine 60 is always root 3 over 2, multiplied by the I. So then, multiplying the 2, you get 1 plus the square root of 3i. So that is the 4th root of the complex number that we started the problem with. Number 3, same idea. You got to recognize that 4, 4. That's kind of nice. What quadrant is this going to be in? Good job. That is the 4th quadrant. So since your leg and both legs are the same, the angle, of course, is going to be what? Great job, 45. And the R value, if it's 4, 4, you got it, 4 root 2. So we know this is going to be a 45, 45, 90. The reference angle on my theta is a 45. But I need to know the real reference that's in the 4th quadrant. So that 4th quadrant 45-degree angle is 315 degrees. So now I rewrite this as 4 root 2 cis 315. And I'm going to take this to the 3rd power. So let's come back up here. So 4 root 2 to the 3rd. We'll have to do that first. Multiplied by cis. 315 times 3 is 945 degrees. So we're going to have to bring in our old friend coterminal angles to figure out what this actually is. Which isn't going to be too bad. We just keep subtracting 215 to remember how to do that. So 4 root 2 to the 3rd. 4 to the 3rd is 64. Root 2 to the 3rd is root 2 times root 2, which is 2, times root 2, which is 2 root 2. Cis. So then we got to do 945 minus 360 a couple times, or 945 minus 720, which is going to be 225 degrees. So we found the coterminal. course. So then we got 128 root 2 cis 225. So now I'm going to evaluate this and put this back in the rectangular form. So 128 square root of 2. The cosine of a 45-degree angle, this is in the third quadrant, that's where the 225 is. So it's going to be negative root 2 over 2 minus root 2 over 2, that's the sine of a 45 in the third, times I. And then just distribute in that 128 root 2. So let's see, 128 and the 2 will cancel out and give you 64. It'll cancel on both of those. And then your root 2 times your root 2 gives you 2. So I'm going to be multiplying 64 times 2 anyway. So I get negative 128 minus 128i. And that is 4 minus 4i to the third power. Fantastic. Alright. Any questions? Good. Following along perfectly then. Next part. Solving and finding roots. Using de Moivre's theorem. It's pretty easy to do. This is just a lot like rose petals and such. What does the square root of 25 equal? Well, that's an easy thing. We should all know that. It's equal to 5. Now, why am I asking you that? It's because if we're solving an equation and we're trying to find the square root of 25, we always got two answers. You'd get plus or minus 5. Well, the reason is because we were solving problems like x squared is equal to 25. So if you take a square root of both sides, you're going to get x is equal to plus or minus 5. It's plus or minus 5 because you're going to have two answers because of it is a second power polynomial. So not too bad. Second power, two answers. If there was no answers, then you'd have two imaginary answers if you remember that. So something like this. X squared is equal to negative 25. If I was an Algebra 1 student, I'd say, no solution. But as an Algebra 2 student, you learn that there are solutions that make this true. We found x was equal to plus or minus 5i. And if we square 5i or negative 5i, we're going to end up with negative 25. So you're always going to be able to get answers. No matter what the degree is, we'll get that many answers. So, in part B, which I just solved, I wasn't even looking, I guess. I just solved part B. You get the plus or minus 5. Alright, so that's all this stuff over here. Okay. So scroll down. So we're going to solve over the set of complex numbers. When this is your directions, it means find every possible answer there is to solve the equation, which will most likely involve imaginary numbers. So, in order to do that, we're going to need de Moivre's theorem. When we want to find how many answers, once we realize how many answers there are, using what's called the fundamental theorem of algebra, then we could know how far apart these answers are going to be in the polar plane. So the answers are equally spaced over 360 like petals and leaves of a rose. So how many answers there are, so say for example, I have, let's say B answers. The amount of answers are B. Okay, that doesn't spell answers very well, does it? Let me erase that. So there are B answers. What you would do is do 360 divided by B, and this gives you your spacing between angles. Just like rose petals. Not angels. Even though several of you are angels, it's actually an angle. So, x to the third equals 27. If I'm an algebra student, I'm taking a cube root of both sides, and I'm getting x equals 3, right? So what this is my initial answer. So then you're probably asking yourself, how many answers are there going to be? Well, it's a good question. You look at the equation and the power of x, and the power of x will tell you how many answers you're going to need. This one right here is our first one, x equals 3. So, if I convert that to rectangular form, that would be x would equal 3 plus 0i, right? Or in other words, it would be 3 cis 0, right? 3 plus 0i is the coordinate point 3, 0, which is 3 away from the pole and at 0 degrees. Okay? So I got that in rectangular and polar. In the end, I'm going to leave everything in rectangular. So then what I do is I realize that there's 3 answers because of the x to the third power. So I take 360, I divide it by 3, which is 120 degrees. So now in the plane, this was my initial answer at 0. My next answer is going to be at 120 degrees, and then I'm going to add another 120 to that and get 240. So these are going to be my 3 answers. Put that in red. That angle, that angle, that angle. 0, 120, 240. If I add 120 to 240, you're going to get 360, which is the same as 0. Just like those pedals. So now we know the angles. So then the next answer is going to be x equals 3 cis 120. So that's our x2. This is our x1. And then our x3 is going to be 3 cis 240. Okay? So we're going to convert each of these to polar or rectangular. They're already in polar. So that would be 3 multiplied by the cosine of a 6. The cosine of a 60 that's in the second quadrant is going to be negative 1/2. And the sine of a 60 is going to be positive root 3 over 2 times I. And then down here it'd be 3. You're in the third quadrant now with a 60, so that's still a negative x value, but now it's a negative y value. Hope you followed that. So now my 3 answers, x equals the set 3, comma, I'm going to distribute that 3 in, so I get negative 3 halves plus 3 root 3 over 2 I, and then negative 3 halves minus 3 root 3 over 2 I. Okay. And I promise you, if I cubed any of those 3 numbers, I would get what number? Yep, you all got it at one time. Good job. 27. All right. One more. Okay, so now I got to get the initial. Use algebra to get the initial. So I'm going to subtract 64 from both sides. 2x to the 5th is equal to a negative 64. Then I'm going to divide by 2. So x to the 5th is equal to negative 32. And then I'm going to take a 5th root of both sides and get negative 2. 5th root of 32 is 2, so negative gives you a negative because it's an odd root. So that's my initial. So -2. And if I graph -2 plus 0i, obviously, you're going to be at 180 degrees, 2 away from the pole. So my first answer here, initial answer, -2 plus 0i, which in polar would be 2 cis 180. So now I'm going to take 360 and divide by what number? Good. I'm dividing by 5. Excellent. So if I divide by 5, you're going to get good old 72 degrees. Now, that's the distance apart. So my second answer is going to be 2 cis, add 72 to 180, and that's equal to 252. So 2 cis 252. My third answer is going to be 2 cis. I got to take 72 and add it to 252, so that's going to be 324. I'm just adding 72. My next answer is going to be 2 cis, add 72 again to 324. So that is going to be 396, which is way more than 360. So I'm actually going to find the coterminal angle. 2 cis, that's going to be, what, 36 degrees? Yes. So that's 4 answers. And then my fifth answer, 2 cis, add 72 to 36. Not 396, add it to 36, and you'll have to find the coterminal. So 72 plus 36 is 108 degrees. Now you will notice, of course, that a number of these answers are all going to be irrational numbers because these are not 40 or 45, 60s, and or 30s, so we're just going to leave it in polar form. There is no shame in that. Alright, unless we want to get some decimals that wouldn't be exact. So those are all my answers right there. So x is going to equal -2. I can just put -2, that's the real number. And then it's going to be 2 cis 252, 2 cis 324, 2 cis 36, and 2 cis 108. If I added 72 to 108, you would have got 180, which would have taken you back to good old number 1 right here, and you just cycled yourself through again. But we got our 5 answers. And that's the notes. I mean, this is what you guys got to do. The last thing in polar. So what I'll do now is uploaded on Schoology are the answers to the assignment that corresponds to this one. So I think it's probably worksheet 9 at this point, but I posted that as in the folders where the solutions to the other homework assignments were when I wasn't there the last time. So right now, in the last 20 minutes or so of class that I believe you probably have, depending on how fast our substitute got the video up, would be time for you to look at the homework assignment and check your answers on that. Okay, and then if you have, we have a quiz tomorrow. The quiz tomorrow will be on everything complex number. So all of this, all of Monday's stuff, and all of Friday's stuff. Okay, all will be on the quiz tomorrow. We will take we'll review everything on Thursday, and then you got your test on Friday. Looking forward to some good things on that test. All right, thanks for paying attention, and have a nice rest of your day, because you deserve it.